Hello and welcome to KISS Math. We covered the basics of solving equations in our last video. This video will go over examples of more complicated equations. Throughout all of these though, the steps will always be the same. Number 1, simplify. Number 2, move unknown crap to one side. Number 3, move known crap to other side. And lastly, number 4, eliminate the coefficient.
Finish him!
Okay, so let us begin. So this first example here, 2x minus 3 equals 13 minus 3x. Well, there's nothing really to simplify, so I'm going to start moving my unknowns to the left side, and I'm going to move my knowns to the right side. Now you can do that the opposite way, it doesn't matter, it's really just a preference. So I'm going to move this negative 3 over to the other side, and the way I do that is I have to add 3 here, and if I do that to the left side, I also have to do that to the right side. So I will have 2x minus 3 plus 3, that's 0, so that goes away, equals 13 minus 3x, and now I have a plus 3 on this side. Okay, so I moved all of the knowns to this side here, but I still have this negative 3x piece that I don't know what that x is, so I have to move it to the unknown side. And I do it in the same fashion, right? So if I add a 3x to the right side, this, I also have to do that to the left side. So we will have 3x plus 2x equals 13 minus 3x plus 3x, that's 0. That was the whole purpose of moving it over, so it no longer is on this side. And we still have this 3 over here. So now I can add up the like terms. So I have 3 of these x's over here plus 2 of these x's. So that's 5 x's in total. And then 13 plus 3, well, that's just 16. And now we can just eliminate the coefficient of 5 here that's in front of our x. And the way to do that is divide by 5, right? We're going to do the inverse of multiplying by 5, get rid of it. So if I do that to the left side, I also have to do that to the right side. And then what happens is that these 5's cancel to become 1. So we just have 1 times x, or x, equals 16 over 5. Okay, so we got our answer, but now let's check this answer to make sure that we didn't screw up anywhere. And the way to do that is we take our original equation, which is this guy here, and every time we see an x, we're going to plug in the 16 over 5, and we should get the same number on the left and right side. So if we let's do that. So 2 times this x, so that's 16 over 5, minus 3 equals 13 minus 3 times 16 over 5. And now we just have to evaluate this thing. So we can multiply this 2 by 16 over 5, and that would be 32 over 5 minus 3 equals 13 minus 3 times 16 over 5, that's the same as 48 over 5. And now I purposely left these 3 and this 13 alone because I see this 32 over 5 and this 48 over 5 have the same denominator. So what I'm going to do is I'm going to try and move this 48 over 5 over to this side of the equal sign. And you'll see why here. So I'll do 32 over 5. If I move it over, that means I'm adding 48 over 5 to the right side of the equation, like this. And if I do that to this side, I also have to add a 48 over 5 on the left side. Now, I'm not going to write it out like this every time. I'm just trying to show you what I'm doing here. So 32 over 5 plus 48 over 5, right, because we moved it over. Still have this minus 3 here, equals 13. And since I moved it over, there's nothing left here, right? This 48 over 5 negative and positive 48 over 5 make this a 0. So now I have 32 over 5 plus 48 over 5. Well, they have the same denominator, so I just add up the numerator, and that would be 80 over 5 minus 3 equals 13. And 80 over 5 happens to be 16 minus 3 equals 13. And so 16 minus 3 is 13, and that does equal 13. So our answer checks out, and we know that x equals 16 over 5. Remember, that's going to be our answer, not 13. So we go back up here, and we say, oops, that this is our final answer here. Example 2. 7x plus 5 minus parentheses 2x minus 15 equals 10. So the difference here is that we have this parentheses telling us that we have to do our 2x minus 15 first, according to PEMDAS. The problem is I don't know what x is, so this doesn't really mean anything to me. I can't evaluate this parentheses. So I'm going to simplify this equation by just distributing this negative here and getting rid of the parentheses. So that's kind of the tricky part of this problem here, is this is actually a negative sign that you can distribute here. So I'll show you what I'm talking about. So let's do 7x plus 5. And now I'm going to distribute this minus sign to this guy and to the negative 15, right? This is the same thing as a negative 1 here. So, okay, let's do that. So minus 2x, and then a plus 15 equals 10. So if you didn't follow that, I have a separate video on the distributive property. That should help you out. Okay, so now we're going to move all the unknowns to one side and all the knowns to the other side. So I have 7x and a negative 2x. So in total, I have 5x's, right? So 5x plus 5 plus 15 equals 10. Well, this 5 and the 15 are known, right? So I'm going to have to move it to this other side here. So let's go ahead and do that. So 5x equals 10. And again, I subtract 5 here and I subtract 5 on the other side, right? So minus 5 minus 15. And that's equal to 10 minus 5 is 5. Minus 15 is a negative 10, right? So at the end of all this, we have 5x equals negative 10. Now I need to eliminate this coefficient here, and I do that by dividing by 5, and dividing by 5 on both sides. This cancels out, and so we just get x equals a negative 10 divided by 5 is negative 2. Okay, so now we're going to check our answer again. So our original problem was this guy here. And I'm going to plug in a negative 2 every time I see an x. So 7 times negative 2 plus 5 minus 2, negative 2 is 15, close parentheses, equals 10. So 7 times negative 2 is negative 14, plus 5, minus, parentheses, I'm going to do everything in the parentheses first here. So 2 times negative 2 is negative 4, minus 15. Still got the 10 down there. Okay, so I'll simplify as we go along. Negative 14 plus 5, that's a negative 9, minus. And now in the parentheses we have negative 4 minus 15, so that's negative 19 equals 10. And this is essentially negative 9 minus a negative 19. And two negatives like that, that's the same as addition, right? So I'm going to rewrite that as negative 9 plus 19. And if I do that, I get 10. And 10, that's also what we had on the right side. So we know our answer is correct here. X equals a negative 2. Example 3. 1 over 5 equals 4 over b. So b here is our variable. And this one looks a little sketch balls because b is on the bottom here and we've not run into that situation yet. So the way to handle this is I don't want b on the bottom. I want b on the top because then that makes more sense and I can solve for it easier. So the trick to do is multiply both sides by b. So if I do that, I have a b multiplied here and a b multiplied on the right side. So what happens is I have b times 1 is just b, right? b over 5 equals 4 over b times b. Or I can write that as b over 1. And I see that now this b will cancel with this b. And that's what we wanted, right? We wanted to get this b out of the bottom and we brought it to the top. But what happens is the b goes on the other side of the equation, which is fine. So we have b over 5 equals 4 over 1, which is just 4. So now we've kind of isolated the b, but we still have this, divided by 5 over here. This is essentially our coefficient, right? Another way I can write this would be 1 over 5 times b equals 4. It's just a different way of writing this fraction, but it makes it clear that 1 over 5 is our coefficient. And the way to get rid of the coefficient is you can either multiply by the reciprocal, right? So the reciprocal of a fraction is the fraction flipped. So in this case, the reciprocal of 1 over 5 is 5 over 1, like that. And if I multiply it on the left side, do the same over here. And so this 5 and this 5 will cancel as intended. And the whole point of that was to get b by itself. And then we have a 4 times 5 is 20 over 1, which is just 20. So b is 20. The other way you can kind of look at this thing is, okay, we had b over 5 equals 4. I guess the simpler way of looking at it would be, okay, I have a divided by 5. The inverse of that is just multiply it by 5. And if we multiply this by 5, we have to do it on the other side. So this 5 and this 5 cancel out to become 1. And we have b equals 4 times 5 is 20. Get to the same answer, just a different way to look at it. Well, I've circled the answer without checking it, but that's okay. Let's check it here. Okay, so this was our original problem. And we said b equals 20, so I'm going to plug in 1 over 5 equals 4 over 20. And so this is already telling me the same thing, right? So if I just reduce this fraction down, so 4 divided by 4 is 1, 20 divided by 4 is 5, and yeah, we get 1 over 5 equals 1 over 5, so that checks out. Example 4, 12 equals 3 over 2y. Now don't get confused with the different ways that people can write fractions. You can write this as 3 over 2 multiplied by 1 over y. But this is not the same thing as 3y over 2. This is wrong. The y has to stay in the bottom because that's where it is in the original form. So let's stick with this format here. So we have 12 equals 3 over 2y. And again, we have a y on the bottom here that I want to get out. And the way that we do that is we multiply both sides by y. So, okay, 12 by y, so that's here. And then I'm going to multiply y on this side. And if I do that, I get 12 times y. And this is fine. You can write y times 12, but normally you write the number first, or the coefficient first. That's just kind of the proper way to write it. But both ways are correct. So 12y equals, now we multiplied this thing by y, and so this cancels out with that, which is what we wanted. And so you just end up with the 3 over 2. Okay, so now we have to eliminate this coefficient of 12. So the way you do that is you divide by 12, right? So you have 12y divided by 12, and then 3 over 2 divided by 12. So I hope you know how to divide fractions. If not, I have a separate video on that. So let's do that. So 12 divided by 12 is just 1. We got y equals 3 over 2 divided by, and I like to draw a longer kind of line here to indicate that, okay, everything below that, that's what we're going to divide by. So 12 over 1. And we can solve this. We multiply the outer numbers, right? 3 times 1, and we put that on top. And the bottom numbers, or I'm sorry, the bottom number is just these inner numbers multiplied together. So 2 times 12 is 24 equals 1 over 8. If you're more comfortable, the other way you could do it is you have 3 over 2 divided by 12 over 1. Well, you flip the fraction and multiply, which is, again, 3 over 24 reduced down is 1 over 8. Okay, so this is our answer. But now let's check that answer and make sure that it's correct. So here's our original equation. And we said y equals 1 over 8. So 12 equals 3 over 2 times 1 over 8. So, all right, we have 3, and I'm going to call that 3 over 1 divided by, so I can reduce this down. So 2 divided by 2 is 1, 8 divided by 2 is 4. So we're dividing this 3 by now 1 over 4. And again, multiply the outside numbers here. So 3 times 4 is 12 over the inner numbers. 1 times 1 is 1. And so we see that 12 equals 12. And our answer is correct. Example 5. Negative 15 equals 3x minus 4 times parentheses x plus 2. So again, we have this parentheses here. Can't really simplify this, but I want to get rid of the parentheses. So what I can do is distribute this negative 4 to the parentheses and get rid of it. So let's do that. So we'll have negative 15 equals 3x minus 4x minus 8, right? Because we distributed this negative 4. Okay, so we lost the parentheses. So now we're going to start collecting the unknowns to one side and the knowns to the other. So we have negative 15. And so we have 3 of these x's minus 4 of these x's. So we'll end up with negative 1x minus 8. Okay, so I see that this minus 8 should probably go over to the other side, so I'm going to add 8 to the left side. So minus 15 plus 8. And we don't typically write negative 1x, we just write negative x. And this 8 here went away, right, because we added 8 to the other side. So we get negative 15 plus 8, that's a negative 7, equals negative x. And we're not done. Remember, we said this negative sign is essentially a negative 1, and negative 1 is our coefficient here. And so to get rid of that, we have to divide by the negative 1. So if we do that, we're going to have a negative 7 divided by a negative 1 equals, I'll write it out like this, negative 1 divided by negative 1 times x. These cancel, and what happens is this negative 7 divided by negative 1, well, negative divided by negative is a positive, so we get positive 7 equals x. And so we go back up here and we're going to check our answer. So we said x is 7. So we have negative 15 equals 3 times 7 minus 4, parentheses x, which is 7, plus 2. Now we just evaluate. So negative 15 equals, so this right side better equal negative 15, right? So 3 times 7, 21, minus 4 times, parentheses, 7 plus 2 is 9. Okay, so negative 15 equals 21 minus 4 times 9 is 36. And negative 15, 21 minus 36, if you punch that in the calculator or do it in your head, you will get negative 15. So check works out, and we know that this answer is correct.
Another one.
6h over 5 plus 8 equals 2h over 5. Okay, so I know that I probably need to move this 2h over 5 over to here and this 8 to the other side. So let's do that. So 6h over 5 minus 2h over 5. We're taking this 2h over 5 and bringing it over to the other side of the equation. That's why it's negative. And then I'm bringing this positive 8 over to the other side, so that becomes negative 8. So fortunately, we have the same denominator. So if you remember fractions, all we have to do is just subtract the numerators, right? So 6h minus 2h, that's just 4h all over 5 equals a negative 8. Okay, so now get rid of our coefficient, and our coefficient is this 4 over 5. And we can do that by multiplying by the reciprocal, which is 5 over 4. And we do it on this side too. So that gives us these 4s and 5s cancel. We just get h equals -8 times 5 over 4. So I can reduce this down a little bit. 8 divided by 4 is 2. Actually, yeah, 8 divided by 4 is 2, and 4 divided by 4 is 1. So we will just have a -2 times 5, which is 10 over 1, or just -10. And here's another trick here. Instead of doing this whole reciprocal thing, we had 4h over 5 equals -8, right? And so what you can actually do is something called cross multiply. And I'm going to write this as -8 over 1. But what you do is you take the diagonal like that. So 4h and this 1 here. You multiply those two together. Put that on one side. And you say equals the product of this other diagonal, which is -8 times 5. And so you would get 4h equals -40. And divide off the 4, you would get h equals -10. Again, we get the same answer, just kind of a different way, maybe a quicker way to do it using cross multiplication. So last but not least, we have to check our answer. So let's look at the original equation. I'm going to copy it down here. So plugging in -10, we get 6 times -10 over 5 plus 8 equals 2 times -10 over 5. Keep going here. -10 times 6, that's -60 over 5 plus 8. And we have a -20 over 5. Now let's start reducing. 60 divided by 5 is 12. So we just have -12 plus 8 equals, and this one would be 4, right? -20 divided by 5 is -4. And so -12 plus 8, that's -4, equals -4. So we've checked our answer, and we know that h equals 10 is correct.
Another one.
Let's keep going. I've got a million of these. X over 3 plus 2x over 5 equals 4. So I do have all of my unknowns here on the left side and my 4, which is a known, on the right side. My only problem is I can't really add these together because these are fractions with different denominators. But you know how to add fractions, right? So first thing we're going to do is find the common denominator. And real quickly, I'll just list out the factors. 3, 6, 9, 12, 15, 5, 10, 15. So 15 is our common denominator here. And so in order to get to 15, I have to multiply this 3 by 5, right? So I will have 5 times x over 15. And then to get to 15 on the bottom, I have to multiply by 3. And so I have to also multiply that to the top. So 3 times 2x over 15. If you're not following me, you need to watch my fractions section. Equals 4. So now I have the same denominator, and I can add up these numerators here. So I have essentially 5x plus 3 times 2x. Well, that is just 6x. And that's all over 15. At this point, I've combined them or added them. Equals 4. And if I simplify this, I will get 5x plus 6x is 11x over 15 equals 4. And I can just multiply to get this 15 out of here. But I can also do this cross multiplication trick that I just showed you, right? So let's call this 4 over 1. And let's cross multiply. So I'm going to take this diagonal here, right? So 11x times 1 is just 11x. And then we set that equal to this diagonal here. So 15 times 4, that is 60. And now I just have my coefficient of 11, which I need to get rid of by dividing it. So if I divide off the 11 here, this cancels. And I also have to divide this side by 11. So my final answer that I get is x equals 60 over 11. Now this one's a little bit hard to check by hand, so I'm going to spare you that. If you plug this into the calculator, you'd get essentially 5.4545. And if you plug this value in for x up here, you will get 4. You can trust me on that.
I like those odds.
Alright, I think this is the last example here. We have a quantity 3x minus 5 divided by quantity x plus 3 equals 8 over 5. So we have all of our unknowns here on the left and our knowns on the right, so that part's done. Now I can't just move this negative 5 over here or this 3 over here. It's part of this parentheses. And the parentheses tells us that this has to be evaluated together first. And the same thing applies to this x plus 3 down here. So this stays where it is. And so I want to try and get this x plus 3 out here from the bottom, because I don't know how to solve for this x while it's down here. So what I can do, I can multiply both sides of the equation by x plus 3, this whole quantity. That's possible, but that's kind of the slow route. If we do our little trick here again, this cross multiplication, it'll go much smoother. So I'll take this diagonal and multiply that together. So it would be 3x minus 5, that's in parentheses, right, times 5 equals, and we take this diagonal over here and multiply. So we'll have 8 times x plus 3. Now it's important to keep the parentheses because that means you're multiplying this whole thing by 5. And in order to do that, you're going to have to distribute it. So let's distribute this 5. So we have 15x minus 25 equals, and then on this side we're also going to distribute this 8 here, so that's 8x plus 24. Now this is something we're used to seeing. We just have to collect the like terms together. So our unknowns here, 15x and 8x. Let's move this 8x over here. And let's move this negative 25 over on this side. So that would be 15x minus 8x, that's 7x, right? Equals 24, and then we're going to move this negative 25 over here, which means we're adding. So 24 plus 25, which is 49. So we end up with 7x equals 49. And if we divide off the 7, we get x equals 7. So this is my answer. Now let's go check that. So I'm going to copy this down here. And I'm going to plug in x equals 7 into the original equation. So let's do 3 times 7 minus 5. And this whole thing is in parentheses, right? All over 7 plus 3. And supposedly that's going to equal 8 over 5. And I hope that's what we get. So we have parentheses. 3 times 7 is 21 minus 5 over 7 plus 3 is 10. Okay, 8 over 5. Not there yet. 21 minus 5. That would be 16. And we still have that over 10 equals 8 over 5. If we reduce this, let's divide this thing by 2 on both sides, or on the top and the bottom. That would be 16 divided by 2 is 8. And 10 divided by 2 is 5. So we do indeed get 8 over 5 equals 8 over 5. And we know our answer is correct.